Welcome back. Today we're diving straight into a massive enterprise project, deploying Supermicro's SuperCloud Composer, or SCC for short, on virtual machines. Now, I know looking at enterprise deployment guides can sometimes feel, well, a bit like navigating a maze blindfolded. But today, we're treating this installation like an epic quest. We're going to journey from raw, unconfigured virtual machines all the way to a fully functional, highly available management platform. It's going to be incredibly rewarding, so let's just jump right in. Our core philosophy for this explainer really boils down to that old classic rule: measure twice, cut once. In the enterprise infrastructure world, I'd say 80% of a successful deployment is actually won right there in the preparation phase. Seriously, if we just take the time to set up our environment meticulously from the get-go, the actual installation later on, it just becomes a victory lap. So we're going to focus heavily on getting those foundations absolutely perfect. Okay, let's dive into this. Before we build anything, we really need to understand what exactly we're building, right? SuperCloud Composer isn't just some simple standalone app you double-click. We are standing up a robust RKE2 Kubernetes cluster here. Picture this. You've got your control plane master nodes at the top, optional worker nodes for scaling out, and nested right inside all of that, a local Harbor registry for your images and charts, plus a super resilient storage backend. Keep this mental map handy, because these are the exact puzzle pieces we're about to snap together. To get there, we'll follow a tight 5-pillar roadmap. We'll start with the architecture overview, move into the exact sizing requirements, spend some really crucial time on the pre-installation prep, run the automated installer script, and then wrap up by learning how to validate and troubleshoot the whole thing like a total pro. So let's kick things off with step 1, architecture and overview. You see, when you run the SCC installer, you're actually spinning up an entire ecosystem. You're not just dropping in a file. The installer places a full RKE2 Kubernetes environment onto your VMs. It sets up those local Harbor registries so your cluster can securely pull its own images, configures a persistent Kubernetes storage backend, which, by the way, is absolutely vital for maintaining state, and finally, it layers the SCC application microservices right on top. You're basically building a self-contained enterprise-grade cloud environment from scratch. How cool is that? Moving right along to Section 2, System Requirements and Sizing. Allocating the right raw physical materials is essentially the very first trial we have to pass. So the crucial point here is that your choice of storage completely changes your hardware requirements. If you're running a single node, you're going to need 24 cores and 80 gigs of RAM. But if you decide to scale out to a multi-node high availability setup, every single node needs 20 cores and 64 gigs of RAM. And here's the kicker. Choosing local Ceph storage via Rook-Ceph means you absolutely must dictate higher CPU and RAM allocations. Sure, local Ceph gives you way higher IOPS and amazing performance, but man, is it hungry for compute resources, so you definitely want to plan your hypervisor sizing accordingly. And when it comes to storage size, 512 gigabytes is your absolute magic number. That is the baseline requirement for your OS drive, but also for your secondary Rook-Ceph data drive and your tertiary SSC artifact drive. And look, I literally cannot stress this enough. When you provision that OS drive, you have to ensure your Linux root file system is fully expanded to use the whole disk. Some default OS installs cap that root partition at 64 or 100 gigs. If you don't expand it, your deployment will 100% crash later when it simply runs out of space for container images. Don't let that happen to you. Which brings us nicely to Section 3, Essential Pre-Installation Preparation. Think of this as laying the foundation of a house. Strict adherence to the details here will literally save you hours of pulling your hair out later on. Now, what's really interesting about this network setup is how unforgiving the requirements actually are. You need clear, direct bridging to the SCC appliances. And listen to this. Static IPs for every single SCC node are absolutely mandatory. Seriously, do not rely on DHCP here. If a node randomly reboots and its IP address changes, Kubernetes will completely lose its mind, and your SCC services will break. Lock those IPs down for sure. Time for a major pro tip. Network Time Protocol, or NTP, is critical. I mean it. Time drift between your virtual machines is the silent deployment killer that sneaks up on you. If node A thinks it's 2 p.m. and node B thinks it's 2:05 p.m., your log correlation completely falls apart. But even worse, your Kubernetes security certificates will fail to validate altogether. You've got to ensure all your nodes sync to the exact same NTP source over UDP port 123 before you even think about starting that installer. Next up, we need to give our initial master node the power to orchestrate the entire installation across all the other nodes. You do this by generating an SSH key using one exact command, ssh-keygen-t ed25519. You're going to run this on the initial master without a passphrase, and then just copy that public key into the authorized keys file of every single other node. It basically turns your initial master into the conductor of an orchestra, letting it seamlessly configure the workers and secondary masters without any hiccups. Then, you're going to face a fork in the road when it comes to persistent data. You have to choose between local Ceph using Rook-Ceph or external storage like NFS or Ceph CSI. Going with local Ceph means you attach extra, dedicated virtual disks directly to your VMs to build a storage cluster inside Kubernetes itself. On the flip side, external storage means you're just pointing the installer to a storage array you already manage somewhere else on your network. Now, if you choose the local Rook-Ceph route, please heed this warning. Providing a dirty disk is without a doubt the single most common reason these storage deployments fail. Your secondary disk has to be completely clean. I'm talking no existing file system, no FS type, no partition table, nothing. And if you've got multiple nodes, the device name, like /dev/vdb, has to be perfectly consistent across all of them. Rook-Ceph needs raw, untouched block storage to work its magic. All right, moving into section 4, running the installer script. Because our preparation was so flawless, you can finally release all that built-up tension. The actual installation is super simple, it's menu-driven and highly automated. And this brilliantly illustrates what happens when you fire up the Python installer script. That prep work completely pays off. It just asks you a series of simple questions. You pop in your network settings, and then you hit this prompt for the storage class. Because we already mapped out our strategy, right? You just select option 1 for Ceph, or option 2 for NFS, feed it the clean disk path or external IP you prepared, and just let the script do all the heavy lifting. From the main menu, you'll guide the installer through this really satisfying 4-step rhythmic progression. First is setup host, which installs the base RKE2 engine. Second, install infracharts, which lays down Harbor and your storage class. Third is push images and charts, where SCC uploads its massive software payloads right into Harbor. And finally, deploy Helm charts, which brings the actual SuperCloud Composer application to life. It's literally just press 1, wait, press 2, wait, and so on. It's that easy. And when step 4 finally completes, victory is yours. The cluster is alive. The installer will prompt you to generate an admin password, and then you simply point your web browser to your virtual IP or master node IP over HTTPS on port 155588. That's the whole shebang. Finally, let's cover section 5, validation and troubleshooting. Because true IT professionals always validate their deployments, and more importantly, they know exactly how to fix the most common pitfalls if something gets stuck along the way. So let's pose a really common scenario. Say you hit step 2 to install the infracharts, but things just hang indefinitely. You go check Kubernetes, and you see your Rook-Ceph deployments are just stuck in a pending state. So why did this happen? Well, the insider secret here is that your disk wasn't actually clean. Often, an old Ceph Blue Store file system is hiding out on the drive from a previous failed installation attempt. To completely obliterate it, you need to SSH into the node and run a specific sequence of commands on that target drive. You'll use sgdisk to zap all the partitions, dd to wipe it with zeros, followed by blk discard and part probe. Once you reboot the node after that, Rook-Ceph will instantly discover the truly clean disk and provision it successfully. Boom, fixed. Let's see how this builds out if you chose the NFS storage route instead. If you ever see this exact error, upgrade failed, context deadline exceeded, listen, don't panic. It simply means Kubernetes timed out trying to reach your NFS server. Almost every single time, this happens because the NFS path you typed into the installer config doesn't perfectly match the exact export path configured on your actual NFS server. Just correct the path in your config file and rerun step 2. So you now have a fully functional, finely tuned SuperCloud Composer environment running perfectly on Kubernetes, but the ultimate test of any platform is how it handles the future. As your managed infrastructure grows, how are you going to handle the increased telemetry and management load? Well, I challenge you to explore the installer's Add Worker Node menu option. Because you completely mastered the preparation phase today, scaling out your cluster tomorrow is going to be as simple as pressing a single button. What will you build next with all this power? Thanks for joining me on this explainer, and hey, happy deploying!